Good morning. So today we are going to look at examples 2, 3, and 4 that go with section 9.5 that we started yesterday. Let me just check this is recording. Okay, good. So, two angles and one side, angle, angle, side, and angle, side, angle, determine exactly one triangle. This is what we did yesterday. Two sides and an angle opposite one of the sides, or side-side angle, may determine no triangle, one triangle, or two triangles. So there's three different situations that we're working with today. So if the case is that A is obtuse, hopefully you recognize the word obtuse. Basically all it means is above 90 degrees, so bigger than a right angle. If it's above 90 degrees, or A is obtuse, and side A is less than or equal than side B, so it's smaller than side B, there's not a triangle. That obviously does not form a triangle. If it's obtuse and A is greater than B, because A is the hypotenuse, because it's across, then there's one triangle. As you can see, that makes a triangle. If A is acute, or less than 90 degrees, and H is greater than A, meaning the height of the triangle is greater than A, there's no triangle. Now, height is something you've maybe seen as far as a triangle goes, but height can be found by multiplying side B times sine of A. If the height is less than A, which is less than B, you are making two triangles out of that. If H is exactly equal to A, they basically share that side, there's one triangle. And if A is greater than or equal to B, they make one large triangle. So we'll kind of circle back to this as we go through every problem. So let's look at example 2. So it says, solve A, B, and C with A equaling 115 degrees, side A equals 20, side B equals 11. So this falls in the category of obtuse because it's above 90 degrees. So it's obtuse. And A equals 20, B equals 11, A is greater than B. So there's going to be one triangle. So then we can go through and solve like we did yesterday for these things. So let's draw out our triangle. We have B, A, C, little b, little c. So we know that A is 115. We know that B is 11, and we know that A is 20. So because we know both pieces of A, let's start with A. So it will be we're looking for angle B here because we have side B. So we'll say sine of B. Remember, you always want whatever you're looking for to be the numerator. Over 11, because we know that, equals sine of 115 over 20. This coincides with what we did yesterday, where law of sines was either the sines on top and the sides on the bottom, or the sides on top and then the sine of the angle on the bottom. So that's where I'm getting that equation from. And we cross multiply just like we did yesterday. So we get 11 times the sine of 115, which is 9.97, equals 20 times sine of B. So then we divide by 20, and you wind up getting sine of B equals 0.498. Now, if you're looking at that answer, you're thinking, this doesn't quite make sense because I can't end my problem with sine of B. So I need to take the inverse of that sine in order to get it. So I'm going to show you my calculator. Second sine, that's the one you're looking for. Now, I know all of you don't have this graphing calculator, but we talked about the Desmos scientific calculator that will have this. I just wanted to show you what the symbol looks like of 0.498. and you get 29.9 degrees because that's what we're looking for. So B equals 29.9 degrees. Remember, B is a degree, C is a degree. So we found B to be 29.9. Now we need to find C degrees. So again, a triangle is always 180 degrees. So 180 minus the 115 given to us from A minus this new 29.9 equals 115 minus 29.9, 35.1. So we found 2 out of our 3 things that we're looking for. Now we need side C. So we do it the same way. We now need to find C. We have now the angle 35.1, and we want to set that up equal to A because we have all the information. So 20 over sine of 115. Multiply it through. Sine of 35.1 times 20 is 11.5 equals C times sine of 115. Divide by sine of 115 on both sides. And C equals 12.7. So all our answers seem reasonable. If this side's 20, that side's 11, it makes sense that that side would be sort of in between them at 12.7. So this works if you have one triangle. Now let's look at an example where you might have no solution. So example 3 says, solve the side-side angle case with no solution. So they give you A equals 51 degrees, side A is 3.5, side B is 5. Now again, you want to go back to your chart. This falls into the A is acute because it's less than 90 degrees. So it's going to be one of these 4 options here. They do tell us, so acute. They do tell us that A is 3.5 and B is 5. So A is less than B in this case because 3.5 is less than 5. So let's look at a case where A is less than 5, or sorry, A is less than B. And it would be not on there because that one has B, that one has B, right? So now we need to find H because we have nothing where we have A and B being less than each other. So to find H, remember you do H times B sine of A. B is 5, sine of 51. And let's see, 5 times sine of 51 equals 3.88. So now 3.88 is greater than 3.5, or H is greater than A. Now let's look back on here, see if we have something for that. This one, H is greater than 3.5, meaning the height of the triangle is greater than the side. So if there is no triangle, you can't find the measurements of said triangle. Hopefully that makes sense. All right, so let's try the next one. Solve a side-side angle case with 2 solutions. So we have a triangle, A equals 40, side A is 13, side B is 16. So this goes into the acute angle as well. And we already know that we have nothing where we have to just combine A and B. So let's find H. So acute, H equals 16 times sine of 40, H times sine of A, and 16 times sine of 40 equals 10.3. So now we're basically saying H is less than A, which is less than B, because H is 10.3. which is less than 13, which is less than 16. There is something that looks like this. H is less than A, which is less than B. So we have two triangles. Okay, so now we not only need to kind of solve through one triangle, but we have to solve through two triangles. So keep that in mind. So I'm going to draw the first one over here, and we're going to work our way through that. So we know that A is 40. We know that side A is 13. We know that side B is 16. So again, we're looking for sine of B first because that's what we don't have. So set up exactly the same as the last one. Sine of B over 16 equals sine of 40 over 13. So 16 times sine of 40 is 10.3 times 13 sine B. Divide by 13. And we get 0.79 equals sine of B. And then remember, you take second sine of 0.79 and you get 52.2. So B is 52.2. So then if B is 52.2, remember C is 180 minus 52.2 minus 40. And you get 87.5. No, sorry. 180 minus 52.2 minus 40, 87.8. So then we need to find C. So we now have the degrees of C. We need to find side C. So that now goes on top. Sine of 87.8 on the bottom. So then 13 goes on top and sine of 40 goes on the bottom. Cross multiply there. So sine of 87.8 times 13 is 12.9. Divide that by sine of 40. C equals 20.2. Okay, so like I said, this does have two solutions to it. So we found one solution. This is one triangle's worth. We now have another triangle that we have to work with. So how this works is we're saying, okay, if we found that 52.2 was B over here, we're basically going to say, okay, 180 minus 52.2 gives me 127.7. This is now the new angle B. Basically what we're saying there and why we're saying it, sorry, this is 127.8. Why we're saying this is because when you're given two triangles, they're on the same horizontal plane. So if one triangle looks like this, the other triangle is the opposite way. So then 180 minus 127.8 minus 40, because A has not changed here. That was our given information. 180 minus 127.8 minus 40 equals 12.2, which is angle C. So now we have B and we have C, and now we need small c. So we have to do C over sine of 12.2 equals 13 times sine of 40. Again, none of this information changed. 13 times sine of 12.2, 2.747. C times sine of 40, divide by sine of 40, divide by sine of 40. and C equals 4.3. So if there is one triangle, you have to do this process once, just like example 1 from yesterday. If there's no triangle, you're done. You don't have to do anything else. And if there's 2 triangles, 2 solutions. So I have attached this reference sheet for you to use. That's definitely step 1, is doing this. I have attached that on Google Classroom. And again, I will be teaching this lesson at 1 today. Good luck.